All right, everybody, we have a big crowd today. Hopefully some more folks will log on as well. Welcome to our webinar. We'll get started in just one moment. Just a note, and we'll say this a billion times, if you are chatting, please make sure that you are chatting to all panelists and attendees, not just to all panelists, because we want everybody to be able to see. So let's see, like Sue, you just sent me that awesome message about your summer reading program. Would you please resend it to all panelists and attendees? So we'll get started. Yeah, let's go ahead and turn the video on. Hey, everybody. Greg, you're getting echo and feedback. Are you getting echo or feedback? Is anybody else getting echo or feedback? If you would let us know in the chat.
Kathy says fine.
Okay, awesome.
No echo seems fine.
Okay, great. Well, anyway, guys, thank you for joining us so much. My name is Brooks Mitchell. I'm joined here by Claire Ratcliffe.
Hey, guys.
And then we have over here off camera, Stephanie.
Hi.
She's going to be in the chat box because we are expecting a pretty big crowd today. We had like 450 people sign up for this webinar, which means we'll probably get half or less of that, but we are expecting a pretty big crowd. We also have Greg Mosshammer in the chat box. He's our web design guru guy. Greg, if you'd like to say hello in the chat box, and if you want to go ahead and drop a link bank in there, we are going to be, let's see. Hey, Greg. So this link bank is going to have a lot of the resources that we're talking about. So like upcoming webinars, activities, how-to videos, things like that. You will find that in the link bank. You can't really click into links on Zoom, but everything we talk about will be accessed through that link bank. So Greg, just put that in there. Sorry. And at the end of this, we will have a certificate of attendance that we will give all of you. It's also going to be at the end at the survey. So when I close out of the Zoom room, it'll direct you to a survey. And at the end of that survey, there's a certificate of attendance. If for some reason you can't find it, just shoot me an email and we'll try to drop it in the chat box towards the end as well. All right, so we already introduced ourselves, Brooks, Claire, Stephanie. Hey, you got a hand in there, and Greg. So this is kind of, Claire just came onto our StarNet professional development team. You'll see she and I doing webinars a lot. You will see Stephanie's hand quite a bit in the webinars that she's going to help us. And Greg, of course, is always in the chat box. So today's agenda, we're going to be covering some really fun scale solar system activities. So we chose scale activities because I find that they're a really accessible way to get into STEM. It's in kind of an easy concept to figure out as a facilitator and as a patron, this idea of like, oh, there's a lot of stuff in space. The planets are much farther apart than we realize. And you know, the sun is a lot bigger than everything else. So we'll get into that. We'll show you 4 different activities that you can use to kind of demonstrate that. So I'll give you a few little intros, reminders, resource direction. We are part of the Star Library Network. If you have not joined the Star Library Network, please do, starnetlibraries.org. It is free professional development resources and community engagement resources, partnership resources. Our goal is to bring STEM to you guys in the library setting. So we've been doing this for quite a few years now. I've been with StarNet for 2 years, and I'm always blown away by how awesome library audiences are to work with. You guys are the coolest informal educators, and it's great to work with you all. If you go to StarNet, there's a few different things you can navigate around. First and foremost, part of what we're doing with this webinar and with just our general efforts this in 2019 are preparing you all for the universe of stories. So through our NASA at My Library project and StarNet, we're partnering with a collaborative summer library program to support over 16,000 libraries. And we'll get into a little bit more of that and what that is. But on our StarNet website, all the activities that we're going to be talking about today are on our STEM activity clearinghouse. So there's about 200 plus different professional development activities on a wide range of different content areas, all falling within that STEM wheelhouse. And we try to we've curated these from across the web from different really good vetted resources like NASA or the Discovery E-Engineering or other websites, the Science Museum of Minnesota, places that we know produce really high quality activities. I think the inception of StarNet, people were thinking, you know, we found that a lot of librarians were going to like Pinterest or finding not so great, reliable, vetted activities. So this is our attempt to bring all the good ones that we know about into one place that you guys can easily sort based on content area, based on age group, based on cost, based on time. So yeah, go check it out. So I'll just give you, I always put the slide up there. We'll give you like 20 or 30 seconds to take a screenshot if you want. If not, this is all in the link bank, so you don't need to frantically be screenshotting. You can just refer back to this in the link bank. Greg, probably a good time if you want to drop the link bank in there one more time in the chat box for everybody. Okay, so poll question. Let me go ahead and launch this. And so to find your polls, I'll launch it. You'll have to go into your toolbar and click on the poll button. You should get a little notification when I launch it. And let's see. Okay, so I just launched it. I'll give you guys a minute. It'll give you about 5 more seconds. All right. Share these results. Hey, most people have registered for the Summer of Space. I'm glad we had some what the heck is that, because that's going to be my nice, smooth, seamless transition into our next slide, which is all about our Summer of Space website. So this is our, because CSLP, 2019 summer reading theme, that's huge, but there's also big space science things that are kind of coinciding with that this year. So we have, well, 2018 was like the 40th, or it was the anniversary of NASA as an entity, the 60th anniversary of NASA as an entity. This year is the 50th anniversary of the moon landing, of course. So there is a lot of buzz about the Summer of Space, and we've curated this website with different resources from around the web, and from NASA, to put them all together. So we have, if you go to our Summer of Space website, we'll have all the CSLP activities that we have on our clearinghouse all in one place for you. We have a chance you can register and you can potentially win a Orion Star Blast telescope. You can get our CSLP newsletter that we send out that has a lot of free resources, free opportunities. I think we just announced something in our last newsletter that was like a giveaway. So there's a lot of opportunities there. You'll get put on our CSLP or our Summer of Space map as a registered participant. So really cool stuff. And again, this is all free. None of this costs you any money. So definitely go and check that out. So I wanted to introduce a couple of webinars that are coming up. One is with a different, it's through the Astronomical Society of the Pacific, and the other is through us, StarNet. So the first one will be, gosh, I guess next Tuesday. And these are some partners that we've had with a couple of different projects. Andy Fracknoy, I do not know Jeffrey Bennett, but I'm sure he's a great presenter. And their webinar topic is difficult questions in the era of alternative facts, dealing with pseudoscience related to astronomy. That sounds pretty fascinating. It's a little bit different than our webinars, in which we're just showing you how to do fun hands-on activities. But that sounds like a great webinar. I hope you all can check it out. I put a hyperlink shortener in there, but that hyperlink should also be in your link bank as well. If you can't find it, it is through the Astronomical Society of the Pacific. You can find it through their website, or you can shoot me an email and I'll direct you to it. The next one is our Mars in May webinar, which I just launched a couple of days ago. So a lot of folks probably haven't seen it. So we're just going to go over some activities that have to deal with Earth's, close neighbor, or our red neighbor, I should say. And we'll be talking a little bit. We might check in on the InSight mission, see how that's progressed since the last time, which was, I guess, last May. We did a Mars webinar as well. So check that out. There will be more to come. I know you guys you're gearing down for the summer, and once it's summertime, you're not going to have a ton of time to sit at your desk and watch webinars because you're going to be doing such awesome programming. But we'll try to have some offerings in the summertime as well. And don't forget, all of these are recorded and uploaded to our YouTube channel and our website. Okay, so we wanted to get things started. Hey, we did pretty good. Wanted to get things started by doing some poll questions, kind of some icebreakers. So I have a few of them here. Go ahead and launch them. Okay, so all three of these should come up. Don't feel bad. These are really hard questions. So this is from, well, I'll let you answer first, and then I'll explain what activity this is from and how you can access these. And we'll give about 10 more seconds to answer. All right, 3, 2, 1. Let's see here. All right, so you guys overwhelmingly voted that the sun's surface was hotter than lava. We also voted that a sunspot was hotter than a lightning bolt. And we voted that the sun's core was hotter than the Earth's core. So let's see what the actual answers are. Okay. So you are right. The sun's surface is absolutely hotter than lava. I guess, pretty much anything on the sun is going to be hotter than anything on the Earth to a certain extent, Then we have a sunspot is hotter than lightning. That is not true, actually. And there you go. There's the exception. Lightning is super hot at 52,000 degrees Fahrenheit. A sunspot is the coolest spot on the sun's surface. So that is why it appears cooler, or it appears darker, if you will. So there's a magnetic loop there going. And then lastly, yes, the sun's core is hotter than the Earth's core. The Earth's core is hot, but the sun's core is, I want to say, 2,700 times hotter. I think that math checks out. So just a fun little set of questions there. This comes from a game that we have on our STEM Activity Clearinghouse. And I just kind of threw this in at the last minute. We're not going to be focusing too much on it, but it's called Sorting Games: How Big, How Far, How Hot. And it's a very simple set of images and answers about how big different materials are, or how big this set of like 5 to 10 cards is and how far they are. And you can have your patrons go and categorize them in different ways. It's a very simple activity. Again, it's called How Big, How Far, How Hot. Greg, I know I didn't include that one, but if you can pull that from the clearinghouse and put it in the link bank real quick. And I like that activity because it kind of does deal with scale and with this idea of, different sizes, different distances apart. And again, scale activities are what we are focusing on today. So let me close this. And we'll get to our first activity. Awesome. So once again, scale activities, they are approachable. It's a simple concept. Just this idea of like, hey, things are a lot bigger than you think. Things are a lot farther away than you think. And there's so many different ways that you can approach this. So I would really recommend giving at least one of these activities a shot in your library's STEM programming for this summer. So the first one we're going to do, Pocket Solar System. I like Pocket Solar System for a few different reasons. It's relatively quick. You can spend anywhere from like maybe 5 to 10 minutes. You can maybe do 20 or 30 minutes, but it's not a long activity. It gives your patrons a chance to be a little artistic if they want. So personally, I'm not super. Are you artistic, Claire?
Not the best.
Okay, right. So I just did. I'll show you my Pocket Solar System. I just used a marker. But with your patrons, you could have them draw different images of the planets. You could have them
decorate the whole tape.
Yeah, right. Put little, I don't know, asteroids for the asteroid belt or something like that.
Star stickers.
Yeah. The last reason I love this activity is because it is super cheap. You need one roll of like receipt paper, and that would be good for a lot of kiddos. So receipt paper, a pencil, a pen, maybe some colored pencils, but super easy to do. So I was thinking about like how you would want to approach this activity. I think this would be good if you're doing a story time. So if you read a story time about the solar system and then you were looking for an extension after that to do a hands-on activity, I think this would be a really good chance for that. You wouldn't really want to make this the focal point of a program just because it's kind of short and sweet. But yeah, I guess we'll go ahead and jump right into it. So I'm going to be standing up back here and showing you how this activity works. So again, all you need is receipt paper. And you'll start out by tearing off, you want to tear off maybe the length of your body. It's great because you don't really have to measure anything. You don't even need a measuring tape. It's kind of approximation to a certain extent. So about, 4 or 5 feet of receipt paper will do you good. Thank you. So I already have mine made, but I'll kind of walk you through the different things that you do. So on one side, you're going to put the sun, right? Center of our solar system. So on one side, you'll have the sun. On the other side of the receipt paper, you will have Pluto. Okay, now I know I don't want to get anybody riled up about Pluto being a planet or not being a planet. So we're going to treat that as the farthest object in our solar system for this activity. So we have the sun on one side, we have the Pluto on the other side. And our first step is to fold our receipt paper in half. Now, what do you all think, if you want to put in the chat box, what do you think is halfway between the sun and Pluto? What object in our solar system is halfway between the sun and Pluto?
Jupiter, Uranus, Jupiter. Pluto is my favorite, no matter what its status. Fair, Veronica, fair.
All right, okay. So halfway between Jupiter and the sun, or halfway between the sun and Pluto.
Jupiter.
If you have an older audience, you can make the joke, what's halfway between your head and your toes? That's right, Uranus. So halfway, after you fold it, undo the crease, make a mark halfway where you folded it, and you'll put Uranus right there. So I think we want to go ahead and knock out some of these like outer planets. So we have Pluto at the top, we have Uranus halfway. We're going to fold Uranus and Pluto together. We're going to make a little crease right there in the middle. We're going to undo it. I think everybody should get this one. What do we think halfway between Uranus and Pluto is?
Neptune.
Okay. Oh, thank goodness. Okay, so we've got our outer edge of the solar system, and just these 3 planets, think about this, have taken up half of our receipt paper, okay? So quite a bit, just these 3 planets. So now we're going to focus on the first half of the solar system. So we have Uranus on one side, we have the sun on the other side. We're going to fold those 2 together. Crease it down the middle. And what do you all think is halfway between the sun and Uranus? What's your guess without looking?
Saturn. Jupiter.
Totally looked. That's right. It's going to be Saturn, okay? So here's my only artistic ability. I drew a little Saturn with a ring on it.
It's beautiful.
Thank you. But you can see if you had some younger patrons or even older patrons that wanted to really decorate this and take it home, that would be awesome for them. Okay, so Uranus to the sun, halfway is Saturn. So now we are dealing with just 1/4 of this original, 4 feet of receipt paper. So let's fold the sun and Saturn in half. From there, I'll go ahead and tell you guys we get Jupiter. Okay, so this distance, let's think about this distance between Jupiter and the sun, or Jupiter and Saturn is quite a bit. And then Jupiter and Pluto is all of this extra. Okay, so now we're moving in and we just have I guess it's like 1/8 of the receipt paper, the sun, Jupiter. We're going to fold that in half. What do you think, Stephanie? What's halfway between the sun and Jupiter?
The belt, the asteroid belt.
Very good. All right.
Nice.
It's almost like you work at a place called the Space Science Institute or something.
Right.
So halfway between the sun and Jupiter, we have the asteroid belt. So now we're really getting small. For this one, for the last step, I would recommend folding the sun to the asteroid belt. And then go ahead and just do fold it in half 2 more times. So go ahead and do all those folds together because we just have those inner rocky planets that are really, really close to each other. So you should have 3 different folds. And I know you can't see this, but that's okay. The first fold closest to the sun, we're going to put Venus. The second fold, the first fold closest to the sun, we're going to put Mercury. The next, we're going to put Venus. The next, we're going to put Earth. And the last, we're going to put Mars. I think I jumped the gun on that. We're going to do the sun to the asteroid, fold that in half. You get Mars. And then from there, from Mars to the sun, fold that double. And you'll get those first 3 planets. Okay, so again, the sun to the Earth is going to be this little bit. And the Earth to Pluto is going to be this little bit. Wow, we must have a really, really big solar system, you all are saying in the chat box right now. That's right, we do. So that is Pocket Solar System. Again, as you can see, cheap, easy. There's a great how-to video from the Astronomical Society of the Pacific. So if you're like, Brooks, I can't see anything that you're doing right now, go check out the how-to video. It's really great. Super easy and accessible activity.
Cool. All right, thank you, Brooks. That was really awesome. We're going to move on to our next activity, the solar system bead activity. So what Brooks was touching on just now is just how immense our solar system is and how kind of incomprehensible it is to even, imagine that. And so what's so great about these little scale activities is it gives a visual model that kids can hold, kids can see, they can really compare. Like he said, that first little section of tape had 4 planets in it, and then the last half of that tape had only 3. It really helps us to conceptualize these hard to picture concepts. So the solar system bead activity, you will be constructing a scale model using beads and string. And the materials that you'll need is large craft pony beads in 11 different colors, because each color represents a different planet. 5 meters of string for each student. That's actually quite a lot of string. So in terms of facilitating this at your library, this would be a better activity for kids, I would say at least 8 years old and up, just because it requires that dexterity of tying knots with 5 meters of string, which I'll show you in a minute. I get frustrated with that. Yeah, it can be a little tricky. But other than that, it's a very, very simple activity. A small piece of cardboard, about 10 centimeters by 10 centimeters, that's optional if you want to wrap your little model around it as a holding place. And then some kind of measurement tool. So meter sticks, rulers. I found that a measuring tape was pretty essential, especially when you're getting to measure Pluto from the sun. With this measuring metric, you have to measure about over 190 inches. So that's a lot of like meter sticks or rulers next to each other. So having a measuring tape, in my opinion, is really key for this activity. And then you will need student worksheets, which the students will use to make some really basic calculations.
Yeah, I would say this is like this could even be a take-home activity if you wanted to leave this on your reference desk. I know it requires some materials, but you could even leave like a package of beads and say, hey, do you want to construct a model at home? Yeah. A lot of different options with this one. I kind of like how we're tiering out, like we're going from this simple, easy, low-cost activity. This one's a little bit more complex, and then the other two will be more complex than that.
Yeah, and what's great about this activity and the one Brooks just showed is they can be done indoors. So if you're having a star party and let's say the weather is not working out for you, these are great activities to pull out and have kids do to still have that experience with space and our solar system.
Yeah.
Yeah.
Awesome. So do you want to go and show them over on the Elmo cam?
Yeah, real quick. I want to just explain the next slide real quick. Yeah. So this is that student worksheet. It's the planet distance chart. On your student worksheet, it won't have the scale value in centimeters. That's something that your students can calculate on their own if you're feeling comfortable adding some math into it. So basically, astronomers have measured the distance from Earth to the sun, and they call that 1 astronomical unit, or 1 AU, which is equal to about 150 million kilometers or 93 million miles. Again, things that are really hard for my brain to even comprehend, the just enormity of that. But that's the distance of the sun to the Earth. And by calling that 1 AU, it makes it really easy to calculate distances to the other planets from the sun. And in order to scale that huge distance down to something that you can do for this activity, what you do is you multiply that AU number by a scale value of 10 centimeters. Super simple, actually. All you have to do is move the decimal point over 1.
Wait, Claire, are you asking librarians to do math in their programming?
They got this.
It's super simple.
Yeah.
Powers of 10.
Powers of 10.
I personally would shy away from doing math with patrons in an informal setting. But this is a super easy, accessible way to bring that into STEM and STEAM.
Absolutely. And you can even just use this answer key if you don't want the kids to go through the calculations themselves. But like I said, it's very simple. So it's an order of 10. So let's look at Mercury here. That's 0.4 AUs, or astronomical units. Multiply that by an order of 10, and you just move that decimal point over 1, and it's 4 centimeters. And that's how much you'll measure on your string. Or let's look at Pluto, 39.5 AU. That comes out to 395 centimeters that you'll measure. But yeah, I'm going to hop over and actually show you how to do the activity. So we're going to turn off the...
Yeah, we're going to just bear with us. We're going to transition to a different view, and then we might just do a quick little audio check to make sure that's all working. So if anything, if you're like, hey, I can't see all of a sudden, or I can't hear, let us know in the chat box and we'll figure it out.
Okay, so here before me, I've already kind of pre-beaded it, but basically the first thing you'll do is cut out 5 meters of string. So I'm just going to show you real quick. That's a lot of string, quite a lot of string. And so you can really help facilitate this by pre-cutting the string before your patrons get there. Or if it's an older audience, they can cut it themselves and measure it themselves. But yeah, so you'll have string, you'll have a bunch of different beads of different colors, and you'll start by tying the biggest bead you have. I just chose this cool yellow button to the very end. And what do you guys think that represents?
I'm gonna say the sun.
Yep, you are correct. Good job. Yes, so the sun will be your starting point, and you'll string it on and give it a double knot. So the first one's pretty easy. It gets a little harder navigating 5 meters of string and beads and double knots. So like I said, not the best for like pre-K. You have to have that dexterity. The first few planets you can rule out just with a ruler. You don't necessarily need that measuring tape quite yet. So I'm going to show you the first 3 planets. So you can see that chart there. Mercury is 0.4 astronomical units away from the sun, and that calculates to 4 centimeters, which is about 1.5 inches. So you'll just go ahead and start with your sun there, go out to about 1.5 inches, and I'm going to use a red bead. These colors like somewhat match the actual colors of the planet, so they do have a significance. Go ahead and give that a double knot. Like I said, it can be a little tricky with 5 meters of string. And I'm just going to go off camera to do this real quickly.
It's a lot harder when the pressure's on.
Yeah, so I mean, just keep in mind, you know, you may have to deal with things getting tangled and stuff like that. But double knot and okay, all right, and there I have the sun and we've got Mercury. All right, so Venus is our next planet. Let's see, I'm going to go ahead. I think I dropped my Venus bead down there. I'm actually going to show Earth this time since we all are very intimately familiar with Earth. So, and for Earth, I am using a blue bead because, you know, water and everything. So you'll string your bead on, and it says on the chart, again, like I said, Earth is 1 astronomical unit. It's kind of the measurement that we use to compare all of the other planets, and that comes to 10 centimeters. So very basic math. It's nothing to really be afraid of. And 10 centimeters is about 3.9 inches. So I'm going to say right there is good. I'm missing Venus, sorry.
Did you drop it behind there?
Yeah, it fell. But you kind of get the picture. You just measure out each planet and go ahead and tie it to your string. Okay. And you just continue that, so on and so forth. I'm going to show you my completed model just so you can get a better picture of how close and how far away planets are to each other. So here we go. Here we have the sun. We have got Mercury, Venus, Earth, Mars. Stephanie, do you remember what this little black bead all the way out here is?
Belt.
Yes. You're very good at identifying the asteroid belt. So we have the asteroid belt. We're going to keep going, and you can see how the farther you get away from the sun, the farther the planets are from each other. So after the asteroid belt, we have Jupiter. Way after that, we have Saturn. Beyond that, way farther out, Uranus is my purple bead. We've got, let's keep going. There's Neptune. And then this, I really like this activity too. It gives you the option to have the discussion about Pluto in terms of the fact that dwarf planets, here's Pluto, all the way at the end. It's about 493 centimeters away from my little sun bead. So that's where you really needed to use a measuring tape. But the cool thing is this dwarf planet doesn't have a very steady orbit. It oftentimes is before, or it can be much closer to Neptune. So you can kind of tie on multiple Plutos if you want to demonstrate the irregular orbit of Pluto, which is really great. One more thing I want to talk about. When you're doing this activity, it's important to note. So we have all of our planets. I'm going to go back to the front just because you can see it better on the camera. We have all of them in a line. Now, planets are never actually in a line like this. So that may be something you want to bring up with your patrons, just so you're not reinforcing any misconceptions. They may look like they're in a line if you're looking from the Earth at the night sky, but they're never in a straight line like this. So that's just something to note. Another cool thing about this model is it can help you answer questions such as, here's one example, which is closer to the Earth, the Sun, or Jupiter? This model makes it very, very clear. So if you look here, we have the Sun and Earth, and then let's go from Earth to Jupiter. Earth to Jupiter is way farther. So you can tell with these models, you can answer all sorts of questions. And that's what scientists do with models like this. They're using it to just explore, to navigate, and to really answer all of these questions. So yeah, but that's it. It's a really simple hands-on activity. It doesn't require a lot of materials. Like I said, you can do it indoors. Yeah, and it's a lot of fun.
Awesome. Thank you, Claire. Oh yeah, do you want to bring, we'll go back to this view and we can bring the string out.
Oh, sure. Yeah, sounds good. Okay. Okay. All right, so I don't know if you guys can really see, but maybe Brooks, if you want to hold this side. It's a pretty long, it's a sizable length of string. Like I said, over 190 inches. I actually want to also give you another tip. So the instructions say to cut out 5 meters of string per patron. That does not take into consideration the string that you lose when you tie a knot. So I actually had to tie on more string when I made this because I ran out of space. So I would actually do maybe 5.5 meters or at least a couple extra feet to take in consideration the knots. So
nice, good setup. Very cool. Thank you so much, Claire. So these are a couple of really cool, easy, accessible activities that deal with the distance between the planets. What is one thing that these activities are missing, though? We're talking about the distance between the planets, but it is missing the, Stephanie?
I have no idea.
The size, the difference in size between the planets, right?
I think Christina got it. They said size.
Yes,
Nice.
thank you. Yeah. So that's great to visualize the distance. And if you have younger patrons or maybe you're not quite as comfortable with the content, that's a great introductory way to start talking about space science. But now we're going to kind of ramp things up. We're going to do 2 activities that take into consideration the relative sizes between the planets as well, or the relative distances between the planets as well as the sizes. So this next one I'm going to do, and Claire, actually, if you want to go set up at our next position, we'll see Claire again shortly. Hopefully she doesn't freeze in the meantime. But this activity is called Jump to Jupiter, and this is truly one of my favorite activities. You know, I said earlier I wouldn't base a whole program around Pocket Solar System. I would base a whole program around Jump to Jupiter. The idea here is that we're once again using visual representations to talk about the different sizes of the planets. So in this one, let me go back here and grab it real quick. Our sun is going to be a grapefruit. So you can do a grapefruit or a pomegranate. I like doing the grapefruit because it is orange. So you'll be using your sun as a grapefruit, and that's how we're going to start things off. And let's talk a little bit about the different sizes of the planets and the different sizes of some of the other items in the solar system. So why don't we, in the chat box, and I'll pull up my chat as well, somebody tell me, what is your favorite planet in the solar system? Or dwarf planet? Okay, Saturn, Pluto. Let's go to Pluto first, really, because it's like my next slide, so thank you. Okay, so we have Pluto. What do we know about Pluto? Is Pluto an outer gas giant like Neptune or Uranus?
Pluto, love.
Yeah, there's a heart on Pluto. So we know a few things about Pluto. We used to not know much about Pluto until like, oh gosh, the past 40 years or so. We started to learn more and more and more. But the first images we have of Pluto were just a tiny faint dot in the telescope. But as we've sent missions past, we've found more and more out. So we know Pluto is a rocky planet. It's not a gas planet, okay? And I think we all know the answer to this, but is Pluto very big? No, of course, Pluto is not very big. So I want you all to think about, if our sun is a grapefruit, what size would Pluto be? And I'm going to go grab the answer real quick, and I'll be right back.
Blueberry, pea,
Blueberry.
grape, grain of sand, poppy seed, pollen, salt.
So in this, oh, I had it right there. In our in this scale model with the sun as a grapefruit, Pluto is going to be a piece of fine sand. Now I'm holding up this bag, right? I can't hold up fine sand. We have a few small flakes of fine black sand so that patrons can see it. And actually, I'm going to turn the Elmo cam on and I'll show you guys. So for Pluto, we have this tiny, tiny, tiny piece of fine sand. It's even hard to see in the bag, okay? So that's really, really, really small. Who has another planet that they like?
There was Neptune said, Jupiter,
Like a virus.
Venus, Mercury.
All right, let's just go to our next one. We all like all the planets. And we all know what planet this is, don't we? It's red. There's a machine on it that looks like it's man-made. Yes, that is our friend Mars. So again, we'll have a webinar in May all about Mars. But we know Mars is rocky, right? It's not a gas planet. We think it's probably about, it's close to Earth size. It falls within those inner rocky planets. So knowing that the sun is a grapefruit, Pluto is a speck of fine sand, how big do we think Mars is?
Bean, question mark, salt, cranberry, blueberry, grain of sugar.
Okay, good answers. Actually, one of you was right. In this scale model, Mars is going to be a sugar crystal. Okay, so I'll put this fine sand all the way over here. We'll put Mars right here. All right, let's see. Let's go to a bigger planet. All right, so we all know Jupiter. We like Jupiter. We can see the red eye. It is the biggest planet. So thinking about this scale model again, grapefruit is the sun. Speck of fine sand that you can barely see is Pluto. A sugar crystal is Mars. How big do we think Jupiter is?
Apple.
An apple? What?
Orange. Grape. Bean.
Tiffany, Mars is a grain of sugar.
Walnut. Blueberry. Large bead.
Large bead. Okay, I'm seeing some good answers here. Let me run back over. So Jupiter in this model is going to be a wooden bead. All right. So let me pull that out. And actually, we don't have a wooden bead here. We have a glass bead. But the idea being that it's a little bit bigger than a pony bead. Let's see here. All right. So I'm going to go ahead and show you all what the other items that we use for this are. And I have a chart, but I might as well. Actually, let me just go ahead and pull up the chart. All right. So you can see we have a few different options here, and you don't have to use specifically use these materials, but you want to find something that fall within that range. So again, this is pretty cheap because you really don't have to spend a ton of money on getting these materials. The thing you're going to want to think about is getting those materials in a bag and labeling a bag. So for example, like your patrons might be like, there's nothing in this plastic bag except some tiny black flakes, and they would have no idea that that's fine sand. So you definitely want to label that. Now, this is actually a two-part activity. We're going to go check in on Claire, who's doing our Jump to Jupiter course. And the idea behind the second part of the activity is that you're either setting up, it could be a standalone if you had some adult patrons or some teen volunteers that were helping guide people through, but you'll set up somewhat of a course with either traffic cones or some type of marker, like a wooden dowel with signs that represent each of the planets outside. Your patron's job, they don't really need to go and measure the distance, but they want to see how many jumps it takes them to get from one planet to the next. And I'll go ahead and tell you all that they will have an aha moment right when they get to about Jupiter, and they realize that, no, they don't want to jump 37 steps. So again, let me go back to this slide. You can see, and this is actually one of our good friends, Enid Costley. She has set up, you can see Mercury's right over there. Her sun is a softball, so about the same size. That would work. So you set up this course. You can either, once again, use wooden dowels, and you can have a picture of a planet or taped to that wooden dowel, or you could even have that material, that object on that wooden dowel too, to represent each planet. So going back, and sorry for switching through the slide so quickly. Going back, we can see that to jump from the sun to Mercury, it's going to be about 20 feet or 6 meters. But again, it's that kind of approximate measure, and you're adding in that kinesthetic element of jumping and moving around and being active. So it'd be 6 jumps to Mercury, 5 jumps to Venus, 4 jumps to Earth, 8 jumps to Mars. That all seems pretty manageable, right? And then once you start getting outside of Mars, you really start making those connections and those aha moments of Mars to the asteroid belt. That's pretty far. The asteroid belt to Jupiter, that's pretty far, and Jupiter to Saturn, of course. By that point, nobody can really, nobody really wants to jump that far. But if you are limited on space, if you have a sidewalk outside of your library, that's a great place to set this up, as we saw in that picture. If you're limited with space, of course, you could scale it down a little bit. I wouldn't really recommend that because it's a lot of math, and you're kind of getting outside your objects too, and it doesn't really isn't accurate. I would recommend circling back and forth on a gym or in a building. And yeah, I think you could do this probably in a really big gymnasium if you circle back and forth, or you could just set up the first 4 or 5 planets that are close together. So Claire is outside. She's running our Jump to Jupiter obstacle course right now. I don't know why I said obstacle course. I guess it's been snowing, so there's some ice out there, so that'll make it an obstacle course. So I'm going to stop my video camera real quick. I'm going to pull the video camera out there. We're going to check on Claire to see how she's doing. And yeah, so if you'll bear with us for just one moment. So you'll just hit that start video. All right, so we're out here checking on Claire. How's it going out there, Claire? How far? It's pretty cold, isn't it? How far along are you? She's saying she got to Earth, and that's about 15 jumps. So Claire, do you want to go ahead and jump to Mars? You got long legs, don't you? Big jumps. All right, now we're going to go from Mars to the asteroid belt. Are you ready? All right. 2, 3, 4, 5, 6, 8, 9, 10, 11. All right, bye, Claire. Oh, and she's still going. All right, we're going to come back inside if you'll stop the video, Stephanie.
Yep.
All right, thanks everybody. Claire's going to be coming in back in, huffing and puffing here in a minute. So Tiffany, yeah, would you go in a straight line or curve in a circle? That's a great question. For this purpose, I would do a straight line. If you start to bring orbits into play, then they could get a little confusing, but you could certainly wrap around and make it a course. But yeah, if you're being 100% accurate, you would jump to Earth, and then you would have to angle a little bit to find where Mars is going to be in its orbit. That would get a little confusing. I'm not sure that our town is even big enough for that. Well, Cheryl, our next activity that we're going to show you will be perfect for you then. So Neil says, and just a reminder, guys, please make sure you're chatting to all panelists and attendees, as Stephanie just put in there. I'm seeing some great things that are just being shared with me. Neil says we can do this offsite at the Boys and Girls Club. They are at a school with a gym and a large field. We would end up crossing too many roads with crazy traffic. Yeah. Oh, I see. Jump to Jupiter meets Frogger. Yeah. Avoid that, please. Don't do that.
With a track field.
Yeah, a track field would work. And you could go around the track. That would be great. I think the total distance is 593 meters to Pluto. So you could do different lanes, right? So your outer lane would be the inner lane would be like Earth. And then as you keep on going and going farther and farther, you could move to some outer lanes. That's a great idea. And Stephanie, would you mind tilting the video camera if you can up just a little bit? Hunch down here.
Hi, guys. Going up.
You could use your town's lakeside walkway. That's a great idea. Yeah, there's a lot of different options. So the next, Heidi says, why not start with a bigger sun, like a medicine ball, so the planet won't be so small as you move away from the sun? I see what you're saying. The cool thing about this grapefruit is that this is all actually accurate into scale. So it should be small. Hey, Claire, come on back.
Back.
Need some water or something?
Oh, I think I'm good.
Okay.
Just gotta catch my breath.
The altitude. The cool thing, Heidi, and so again, I don't know, I think Heidi, you just sent this to me, but Heidi's saying use a bigger medicine ball so the planets won't be so small as you move away. If you use a bigger medicine ball as your sun, which we're about to do, you have to increase your distance scale a whole lot. So when you use this grapefruit as the sun, when all of your patrons get to Earth, for example, you can have the sun, somebody's holding up the sun, or you can put it in a tree. Everybody turns around and looks at the sun, and that is actually how it is represented on Earth. So that size and distance aspect is accurate. When you get all the way to Pluto, the sun, you're going to barely be able to see it, which theoretically, if you're on Pluto, that is how the sun would appear. Plus, you can eat it when you're done. That's right. I went to go pick up the fruit this morning before work, and the person at the grocery store was like, what do you need all this fruit for so early in the morning? And I was like, I had the coolest job in the world. All right. Let me talk for a second. Let me let you catch your breath.
I will say, I mean, what is great about that one is, I think definitely between the asteroid belt and getting to Jupiter, I mean, you're jumping and jumping and jumping, and you really start to like, not only is that a model that you can see like the other ones we looked at, but it's one you can feel, just like you can feel the immensity of these spaces between the planets, which is really great.
Absolutely. And I would say when you're making those dowels and you're making those stations, again, you could walk a group of patrons through that course, or you could have it set up and you could have the information on the packet, and you could say, you know, how many jumps till the next stop in the station. There's a few different ways to do it. If you do want to do dowels with a sign, NASA has these free solar system lithographs that are great. And when you go to jump to Jupiter on the STEM Activity Clearinghouse, which I know you all will, you're all headed there right now. There's a great how-to video that summarizes the whole activity. B, there are links to different lithographs that you can use, different materials that you can use, a shopping list, and so on and so forth. So please visit it on the STEM Activity Clearinghouse, and you can find some great resources to kind of help you facilitate that activity.
Mm-hmm. I would say too, with that activity, you don't have to have it all in a straight line. If you don't have access to like a big parking lot or a park, you know, you could go around the block. You can make it more interesting, have it just go.
Yeah, somebody was asking straight line or curved line, and then I was thinking, if you throw the orbits in, that gets a little complicated, but like around the track would be good.
Yeah, around the track would be good, around a
outer
block.
lap, football field, so on and so forth.
Yeah.
All right. Are you ready for solar system in my neighborhood? Somebody said, they said, if we did this in our town, you know, I don't even know if our town's big enough to do jump to Jupiter. And I said, well, just you wait and see until the next activity.
Yes. So this activity, solar system in my neighborhood, is a great addition to jump to Jupiter, or you can do it in place of it. For example, if you don't have the space in your community. But basically, the big takeaway of solar system in my neighborhood is you're shrinking the scale of the solar system to the size of your neighborhood. It uses objects to model the size of planets, just like jump to Jupiter, but they are much bigger. We're going to start with a much bigger sun, and so it's a little easier to visualize. I think the smallest object, I don't want to give it away actually, but it's not a grain of table salt. And this uses a neighborhood map to model the distance of planets to the sun. So again, great for a rainy day. You don't have to be outside. You just need to be able to have access to a big map. It needs to be 6 miles in all directions from your location. And I'll talk a little bit about that later. But you can get these maps from AAA.
Oh yeah, I went by AAA to grab maps for this, and they gave me 2 for free.
Yeah,
it's very easy.
So free access to big maps, or you can make your own using something like Google Earth. And just size it to scale.
Yeah, if we have time, maybe I'll jump on and show you how you can do this with Google Earth. But let's do the analog version first, I guess.
Yeah. So we'll do the physical map version.
Yeah, do we do that?
Yeah. Okay, so your setup. First and foremost, you need a big map. So 22 by 32 inches of your community, extending to 6 miles in all directions from your geographic location. So that's your library. So in this example here, in this little image, the star would be your library, and you just need to make sure that the map goes 6 miles in all directions so that you have space for all of the planets. You need 1 food item per planet, just to show the size of the planets in scale. A measuring tape is really helpful if you're going to do the extension activity that comes with this, which we won't really get into, but you can look at that in this lesson plan. Coloring supplies, again, for those artsy patrons that want to maybe color the map that you're using, maybe draw their house or something like that. String, that's going to be your measuring tool, so you really don't need a ruler or anything like that. You're just going to measure out your neighborhood using string. Planet labels, which are these things right here, and coffee stirs. I used a toothpick, but this is so that you have a 3D flag for each planet. Ideally, you would do this on a table or on the floor, and you would have it be a 3D model with these taped to the map. Due to our space, we made a 2-dimensional version just because we're hanging it on the wall so that the camera can see it. So we're not using any coffee stirrers or toothpicks in our example, but that's a great way to make it 3-dimensional.
Yeah, when we show you our example, you might think, oh, that looks a little cluttered. But again, we did 2D on a wall. But you can poke those in, and it would make it a lot more clear. Yeah.
Cool.
Awesome. So I kind of like we did with the last one, I want to ask you guys about your ideas on what the sizes are going to be. So if our sun is a giant beach ball, and Stephanie, is there any way that you can grab that giant beach ball back there?
Yeah.
I'll probably hand it right back to you because it's going to take up the whole frame. But
Okay.
All right, so this is our sun. It's a giant beach ball. You could use a giant pumpkin. You could use a giant orange trash bag or something like that, and you could fill it up. Of course, guys, this isn't, perfectly accurate. Even how much I fill this up, it will change the diameter or the circumference. But it needs to be about was it 55 inches wide?
50 to 55 inches wide.
So this is our sun, and it's a lot different from this grapefruit, right? Really big, 55 inches in diameter. So our poll questions for you, and I'm going to launch them. If the sun is a giant beach ball, what planet? Hold on 1 second. All right. The sun is a giant beach ball. Which planet is a blueberry? If the sun is a giant beach ball, which planet is a lime? And if the sun is a giant beach ball, which planet is a potato? Right? Mm-hmm. Okay. Oh wait, no, it's that one. Yeah. Oh, thanks. All right, you guys are doing a great job. We'll give you about, 10 more seconds to answer. All right, let's see what everybody said. All right, if the sun is a giant beach ball, which planet is a blueberry? Everybody said Earth in first, Venus in second. Kind of confusing because they're pretty similar in size. Which planet is a lime? Everybody said Saturn. Neptune came in second. And if the sun is a giant beach ball, which planet is a potato? Everybody pretty much said Jupiter, with Uranus coming in second. So I'm going to keep these up here. You can exit out if you want, but I'm going to reveal the answers to you all. All right. So our sun is a giant pumpkin. So yeah, we thought, oh, a pumpkin, cool. We can go get that from the grocery store. No, they mean like the giant, like state fair pumpkins. Can't get that at a grocery store. I would recommend something easier.
When
like
we
that.
saw 50 to 55 inches, yeah.
What kind of pumpkins are
rethink.
they growing? Yeah. So let's see. Mercury would be the pasta. Venus would be the blueberry. Earth would be a small grape. And actually, I think I have all those things over there. Oh, right over here. So just to give you an idea, the sun is this big. Venus is going to be this tiny little blueberry. Maybe I'll just set it right on top of there. Okay. Our Earth is going to be a small grape. Small old grape. Ugh. We're just going to put that right on top of there too. Okay. And we'll keep on moving along. Mars is going to be a pea. Jupiter is going to be a large mango or a potato. I got a potato because it was cheaper, but the size is kind of a little awkward there. So you might want to get a mango. Depends. Really, I know the grapefruit might work. I don't know, the potato is a little oddly shaped. It seems more like an asteroid floating through or something like that. But for size purposes, the Jupiter is going to be a potato. And Saturn will be a large orange. Forgot one of those too, if you want to grab it.
Saturn here.
Yeah. Thank you. And let's see. Uranus is going to be a plum. Neptune will be your lime. Okay.
We got that right here.
Yeah, just hold it right there. Pluto will be a grain of uncooked rice. And Aries will too.
Aries.
Aries?
Yeah.
Aries?
So this kind of hits that larger scale. If you're just kind of focusing on planets and you don't want to deal with things like salt, this might be better for bigger crowds. You know, you can actually visualize it in a room with more people.
All right. Earth is a grape sitting on the sun will end up being a raisin on the sun. Christina, that's hilarious. Jordan says, what kind of potato are we talking about here? Jordan, you're right. There's a lot of different potatoes. There's a guide. I think it should be about 5.5 inches wide. So on the activity guide, it'll show you exactly how big it could be. And of course, you could do this with styrofoam balls, like sports balls or whatever, but it's fun with fruit.
Yeah, they give you the actual like inches that it should be, which is really helpful.
Karen says Pluto's always a grain of something. That's funny. Yeah. Hey, Greg, just because we're kind of cutting it close, would you mind go ahead and dropping that certificate of attendance and the survey in the chat box for folks if anybody has to log off at the hour and get back to the circulation desk. But we want to go ahead and show you kind of the extension to a certain, or the distance part of this activity. So if you will bear with us, I am going to stop our video. All right. So here is our solar system in our neighborhood. Let me get it a little bit closer.
Yeah. So like I said, you need a map of your neighborhood that has your physical location of your library and that extends in 6 miles in all directions from that point. So this is a map we got from AAA. It shows our area of Colorado, and I chose the Lafayette Public Library as our center point. So that is the sun. And Brooks is going to, yep.
Right there. So you can see we have a lot of these cards. Can you hear, Stephanie?
Yeah.
Okay. We have a lot of these cards. And again, this is because we have it in a 2D setup. In a 3D setup, it's going to be a little less cluttered.
Mm-hmm. Yeah. So basically, you need a pencil tied to about 20 inches of string. And this is kind of your homemade compass so that you can measure the distance of each planet from the sun using your map scale and draw the orbit.
Yeah. So
we'll just show you a couple that are kind of easy to see. It's hard with those inner planets. So we're going to skip over Mercury and Venus and go to Earth. So that's still very closely in the center there. But Earth is, according to this scale, this model, it would be 150 meters or 491 feet from the sun, which is your library location. So you would use that string to measure the scale with your map and measure out 150 meters. And then another fun part about this activity is you get to, somewhere along that orbit, designate a landmark as that planet. So it's a fun exploration of your own neighborhood. Maybe, you know, one of your patrons is like, oh, my house falls on this orbit, so my house is going to be Earth. In this case, I chose Liquid Mechanics, just a local shop in Lafayette.
Is that a brewery? It sounds like a brewery.
I think it's an auto.
Okay.
Yeah, right?
It could be a
It
brewery.
could.
It's Colorado.
Maybe it's both.
Yeah.
Next, we'll show you Saturn. So Saturn is a scale distance from the sun of about 1,427 meters, or 3/4 of a mile from our center location, the library. And so Brooks would, distance that out, use the pencil and string as a little compass to draw the orbit around the sun.
And then could you tell them real quick, I don't want me to cut you off, but how they could find like the different scale distances?
Yeah, definitely. So your maps should come with a key. I'm going to have Brooks just show this one. Yeah, so down here, there are two different scale options. One is in kilometers and one is in miles. So another useful tool to have with this is a converter. So I'm telling him, you know, Saturn is 1,427 meters away from the library. With this scale, it's in kilometers, so he would have to convert meters to kilometers.
Yeah.
And then use the string to measure that distance. And I just used an online tool. I just Googled a meter to kilometer conversion tool. That way you're not doing any math. You just type in the number and it automatically converts it for you. And you can.
Yeah, meters to kilometers. Pretty easy too.
Yeah, pretty easy stuff. And I chose the Hecla Reservoir for our landmark for Saturn.
Oh, cool.
Yeah.
Nice.
And we'll show you just one more. Pluto seems to be a favorite of some people here. So that is not our farthest one out, but it is a scale distance from the sun of 5,906 meters, or 3 3/4 miles.
Oh.
And I found that Pluto from the Lafayette Library, in its orbit, it landed right on Teller Lake. So that was the landmark I chose for
Oh,
that.
nice.
Yeah. So yeah, it's a fun, it kind of brings in geography, your own personal, it brings a lot of sense of place to these activities. And it would be fun with patrons to kind of explore, you know, what lands on this orbit? What is a place we all go to or we all know of, or a special place to you? And again, you don't have to be outside. You don't need a big space. And you get to visualize, again, how close the planets are to each other and how big their orbits are around the sun.
Yeah, awesome. So for those of you saying, even with Jump to Jupiter, you'd be heading downtown in your small town. With this activity, you might be heading, I don't know, into a different state or something like that. All right, so I'm going to close this out and let's go to the
where you have the different items and you put them in order. And if you do, you get a prize with the food items.
Oh, nice.
Yeah, that's a great idea. One of the things we were kind of concerned about was, you know, we don't want to waste this food. They're really great visual tools and a way to just comprehend different scales. But yeah, finding ways to actually use that food, it would be a great way to not have any waste.
Yeah, absolutely. And I know, or, you know, you could have, if you had snacks at your library or something like that. I know there's a lot of sometimes hesitation using food, especially if you have lower, you know, impoverished families coming in and maybe those kids aren't getting a dinner that night and you're like, oh, I don't want to be, you know, playing around with an orange or other food items when there's some of my patrons aren't eating 3 meals a day. There's always other alternatives that you can do instead of food. So all of these have a food item, but they have alternative or the measurements listed out so that you could find another item like a bead or something
penny,
small.
Things like that.
Yeah, so definitely something to keep in mind. Now, I don't know if I would give a potato to a patron after we played around with it, but definitely something to keep in mind. So Kathy Lancaster is saying summer food program will coordinate meal or snack deliveries. That's great. Yeah. So if you could, you know, combine that with some type of food implementation. That's probably not, it's not the phrase I'm looking for there.
Some kind of food program.
Thanks. Yeah, there we go. All right, everybody. Well, we are at the top of the hour. I'm happy to stay on and answer any questions that you might have. I know some of you, y'all wear so many different hats. You're going to go from this webinar to the circulation desk to a story time to a board meeting or something like that. And just a reminder, our next webinar will tentatively be in early May. We may have another one between now and then. Sometimes opportunities come up to have a cool guest speaker on. So we'll let you know, of course, if you sign up for our StarNet newsletter, it all goes out there first. All right. Well, thank you all for the very nice feedback. We appreciate it. If you have any questions, you can always email me. It's bmitchell@spacescience.org, or Claire, C. Ratcliffe. I'm just going to go ahead.
Yeah, I was going to say, just type them in.
And this is Claire's first feature webinar presentation, so we'll give her a round of applause. Great job, Claire. You'll see a lot more of her.
Yeah, thanks, guys.
Joining me.
It was a lot of fun.
Yeah, I'm telling you, libraries are fun to work with. They're a good group. All right, everybody, we're going to log on out. We will talk to you all soon. Please send me an email if you have any questions. And yeah, good luck with your programming this year. We'll see you guys soon. Thank you.
Bye.